Hey, what's up, everyone? Today's lesson is called I Never Forget a Face. And we're going to be using our triangle congruency shortcuts that we learned, that we saw a little bit, to show that two triangles are congruent. But now, we're not going to necessarily be told which one to use. We're going to have to figure all that out ourselves. And we're going to have to put all those pieces together, right? So let's hop into the lesson. First off, we're starting with our learning goals. Our learning goals for today's lessons is to use triangle congruency theorems to identify congruent triangles and identify the information needed to conclude that two triangles are congruent using side, 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 or angle, side, angle. So in our previous classes, we showed that triangles were congruent through side, 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 and angle, right? We touched on those. Now we're just going to be using them more. This is more of a practice lesson, right? So how can we apply these theorems? That's what we want to know here. How can we do this? How can we use them? So first of all, the way we can use them is by finding this information. So we know that we can use them, but now we need to realize, okay, what am I going to look at, and what am I looking for? That's really the question, is what do I look for here, right? So that is the biggest question that we get. All right, so starting off on our first example, this is on page M241 if you're taking notes in your book, and it says, suppose that AD bisects A and AD is perpendicular to BC. Those are two pieces of information up top here. AD bisects A and AD is perpendicular, that's what that symbol means, to BC. Let's mark that off first. Let's understand what that means and mark it off. So when we say AD bisects angle A, that means that AD, this line that cuts down this big triangle here, cuts the angle A, aka BAC, it cuts it in half. So we could say that these two parts are congruent. These two angles are congruent because when we cut something in half, the two parts that it creates are going to be congruent. And then it says that AD is perpendicular to BC. So AD is this line, like we said, going up and down here. BC is the base of this big triangle. If they're perpendicular, it means we have a right angle here, and we have a right angle here. Beautiful. So that's the information we are starting with right here, right? Now it says, are there congruent triangles in this diagram? Explain your reasoning. So first of all, it says triangles, right? But we only talked about one. I mentioned this big triangle, A, B, C. But when this line cuts down the middle, AD, we have two smaller triangles here, ABD and ACD, right? And those are the two triangles we want to look at, because if you notice, when we cut this line down the middle, it looks like these two smaller triangles are going to be congruent. But we need to show how. How are they congruent? Well, we already said that we have one set of angles up here that are congruent due to the bisector. So let's list that out. Our first step here, I'm going to put number 1. And we're going to say that angle BAD is congruent to angle CAD. So that's BAD is this angle right here, boom, boom. And then we're going to say that's congruent to CAD right here, boom, 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 right? And we want to write why. So for everything we're going to be doing today, we want to ask our question why, and we want to support it with a reason that we know. We need to get in this habit. So this is our statement. This is what our statement is called here. We make a statement, and then we have to say, well, why is that statement true? So our first statement was angle BAD is congruent to angle CAD. And our question why, we want to say why is that true? It's because of the angle bisector theorem. Why does this make sense, right? Since AD bisected our big angle here, that's an angle bisector, which means that the two smaller angles it creates have to be equal, which happens here, right? So that's our first statement. Second thing that we got here, we're not going to go to these angles down here yet. What I want us to notice is that both my triangle on the left, BAD, and my triangle on the right, CAD, they share a side. And that side that they share, let me actually change the color here to emphasize this. The side that they share is this line here, AD. So we could say that AD is congruent to itself. So AD is congruent to AD, right? And this is called our reflexive property. And what the reflexive property means is that something is equal to itself. And since both these sides, or both these triangles, share this side, that means it belongs to both triangles and it is equal to itself, right? So we have a side that's congruent there. And then our last little set that we want to use here, we need to find one more thing in order to use one of our shortcuts, right? We want to find one more thing. We'll say statement 3 is we could take a look at these right angles down here, right? So we could take a look at these right angles. And we know that all right angles are going to be equal, right? This is a property that's just true, right? If you have two right angles, they both equal 90 degrees. That means they have to be equal to each other, right? So we could say that angle BDA, which is the right angle on the right there, or on the left, sorry. And then angle CDA are congruent. And why is that? Because all right angles congruent, right? I'm just going to abbreviate it. All right angles are congruent, right? And now, what do we have here? Well, we just listed out 3 things that are congruent. So does this fulfill one of our shortcuts? Let's take a look. First up, we had an angle, right? And then we had a side. And last but not least, we have an angle. So this does fulfill one of our shortcuts. If you look up here, this is ASA, angle, side, angle. We have an angle, we have a side, and we have an angle, right? And that side is nuzzled in between those two angles. So this tells us that those two triangles are congruent. So we could finally say triangle ABD is congruent. Triangle ACD. Why? Angle, side, angle, congruency. And there we go. We just did what we call a proof, right? This is kind of what we call a proof. We figured out things that were equal, right? We were told information. We used that information to say, hey, these two things are congruent. We pulled out some other information that we could just use looking at our picture, and we put it all together to say, hey, this triangle is congruent to this triangle due to a shortcut that we know, which is pretty cool. Now, this isn't something that's going to come easy to us, right? So a lot of you are probably looking at your screens right now. Maybe you pause this video, maybe you're starting it back up, right? And you're like, I don't know what's going on. This is going to take practice. It's going to take a lot of repetition and seeing more things, right? And recognizing patterns. It's all about, hey, I think I've seen this somewhere before type of mentality, right? It took me a very long time to get a hang of these shortcuts and to get good at them. So I don't expect anyone here watching this video to just be good with it right away, right? So we are going to show some more examples here. So let's hop into another example, right? And here we have another example. We have a bunch of triangles in this one, right? So this one says, suppose angle BBC is congruent to angle ECB, right? That's our first step there. So for my first step, let me underline it, show you what I'm talking about. That's right up here, my first step. And let's mark it off in our picture. Whenever you're given information, always go and like mark your picture up, right? Mark it up. If you are taking notes in a notebook, sketch this picture. It doesn't have to look perfect, but sketch it. So let's mark this up. DBC, where's DBC? We start at D, we go down to B, and we say C. This is this bigger angle here, right? This bigger angle here is DBC. So we put one angle marker there, and we're saying that is congruent to ECB. So ECB is the bigger angle over here, right? Boom. We have those two big angles, right? Now, it also says that DCB and angle ECB are congruent. So let me change my colors here so we could focus up with our eyes. Make this one green. So looking at this little statement there. So DCB is the smaller angle here. So now I'm going to do two angle markers to differentiate it from our red one. right? So 2 angle markers here, right? To show that those 2 are congruent, but they're not congruent to the bigger ones there, right? Now, since we have that information, what triangles are we looking at here? Because there's a bunch of lines going on. It might be a little hard to see the triangles that we're focusing on. Well, one thing I want us to do, and if you're writing in your book or if you even sketch this, kind of scribble out this section here. We're not looking at this section here. We don't care about this. This is not what we're looking at. And I'm going to show you why in a second, right? We are looking at these points here, right? And the triangles that they make. Now, you're still, some of you might not be able to see it perfectly. We have a triangle here, DCB, and a triangle EBC, and they're overlapping one another. Notice that they kind of overlap here and they make another triangle. We're not focusing on this middle triangle, right? Although it's there, I see it, you see it. Oh, I want to get rid of that. Don't want to make a star out of it. Although we both see it, that's not what we want to focus on. So what we want to do is look at these 2 triangles, and hey, we notice when they overlap, they also share a side, kind of like our last problem. They share this side right down below here, right there. That side BC. And whenever they share a side, we can say that's equal to itself. So we once again have a congruency. We have 3 things congruent. So we could say that these are congruent using a shortcut. And it's actually going to be the same shortcut we used as last time. But now let's write down all of our information. So I'm going to use the appropriate colors for each angle, right? Just to kind of keep our thoughts organized. So my first statement is what we have up here. Angle DBC is congruent to angle ECB, right? And this was our statement section. Sorry, that was sloppy. Still getting used to my writing here. And for my Y section, why? Well, why do we know this? Well, mister, it told me up top, right? That's why. We call this a given, right? This is our given statement. So these are congruent. Why? Because it was given to me. It was told that that was true. Next, we don't want to do our other angle yet. What we're going to want to do is put that side, right? The side that we said is congruent. So we follow the order of our shortcut. Remember, we don't have any AAS here, right? No SAA, right? But we have an angle side angle. So let's stick this angle in the middle here. And what is the name of that side? Let's stick the side in the middle there. And what's the name of that side? BC. So we could say that BC is congruent to actually CB if we're following proper writing, since these 2 triangles are flipped, right? Why? Once again, it's our reflexive property. That's our reflexive property. Awesome. And last one is our other given statement, right? And we used green for that one, so I'll choose again. And for 3, our last one is DBC. So we say angle DCB congruent to angle E. Oops, that's supposed to be a BC. And once again, why? It was given to me, right? So we have angle, side, angle. So finally, we can say that these 2 triangles are congruent, just like we did last time. We could say step 4, triangle DBC is congruent to triangle ECB. Why? Angle, side. Whoops. It's math. Uh-oh. Get rid of that. Should be angle, side, angle congruency. And there we go. We just proved 2 more triangles congruent here, right? So once again, don't get flustered if this is super confusing or if you're struggling to see what's happening. If you need to, rewatch this section again to understand it. But if you think you understand, then continue with me to the next problem that we have here. Once again, the more we see it, the more we use it, the easier it is to understand, right? We're not expecting to jump in and be professionals at this, right? The more we work on it, the better we're going to get. So next up, it says, suppose that segment AB is congruent to segment DF. Then angle A is congruent to angle D, and segment BE is congruent to segment FC. So we're given 3 different pieces of information here. This is technically enough information to show that these triangles are congruent, right? 3 pieces is all we need. And we have a side, we have an angle, and we have a side, right? But this has to be in the proper order. Notice up top here, in my little 3 shortcuts, we have SAS, but we don't have ASS. There's no S in math. So we cannot use that, right? So we need to make sure by marking this off in our triangles, are they in the proper order? So let's mark off our first one, right? Right here. Boom. Marking that off. Let me just erase my little mark I made here. Sorry about that. Gotta stay nice and neat. So segment AB is congruent to segment DF. Where is AB? AB is right here. I'm going to put a little marker on it. And then DF, right over here, we put 1 single marker on that. So there's our first one. And while we're at it, and I have this color pulled up, I'm going to write it as a statement. Right? So I'm going to say AB congruent DF. Y given. Right? I'm just going to get in the habit of writing this. Right? A statement, my Y. We change colors, keep things nice and organized in my brain. Go to green. Next, we say angle A and angle D are congruent. Angle A, right here. Angle D, right there. Right there, congruent. I'm going to write that down. 2. A, congruent to angle D. And it's given. Once again. And our last little piece of information here. Let me change colors. We'll change this one to blue. Blue. This is right here. Segment BE is congruent to segment FC. So BE, right down here. BE, boom, boom. And FC, boom, boom. Right? They're congruent. I'll write it down as a statement. I'm sorry, just get my brain line here. I had a brain fart for a second of what I was writing. So BE is congruent to FC. It's given. But one thing I want us to notice here, right? We have an angle, we have a side, and we have another side. Angle, side, side. What does that spell? ASS. There's none of that in math, right? But another thing we need to realize, BE, this segment, that's not a side of a triangle. Neither is CF. That's not a side of a triangle. So would we, even if this was an angle side side, would we have any congruency here? No. We cannot tell that these triangles are congruent. And if you kind of look at it, kind of looks at ABC, this bigger triangle here, is a little longer than DEF. So, no congruent on this one. We actually have an example where there's nothing congruent, right? Because those 2 segments, 1, aren't sides of triangles, and 2, we don't have any ASS in math. No shortcut ASS. Not here, not now, not ever. So once again, this does not work. We cannot prove these 2 to be congruent. Maybe they are, but the information we're given does not tell us that. Next up, our next example. Once again, we're given a bunch of information here. So let's see if we could use this information to prove some triangles here congruent. We change my color back to red, and let's start off with our information that we're given. So it says, suppose that AC is congruent to DB. Right? That's our first piece of information. AC is congruent to DB. So AC is this diagonal line going across here. So I'm going to put that marker right there. And that is congruent to DB, which is our other diagonal line here. Now, in my brain, this already tells me that I'm talking about triangle ABC, this triangle right here, and triangle D or DBC, this triangle right here, DCB, right? So there's a triangle on the left side, ABC, right? And there's a triangle on the right side, DCB. So first of all, we need to visualize and see what triangles we're talking about, right? And now we're like, hey, are those triangles congruent? In my brain, they kind of look congruent. So let's see if we can prove it. We have those sides congruent. Let me write that as a statement. So statement 1 says AC is congruent to DB. Why? Given. Always got to know that why. Let me switch colors and let's look at our next piece of information. So my next piece of information says that AB is perpendicular to BC, right? So AB, which is this segment here, and BC is this segment here. They're perpendicular, which means this is a right angle. This big corner here is a right angle. We're ignoring that line cutting it, right? But we're looking at this bigger angle there. That's a right angle. We also know this is going to stay the same color, that DC and CB. So once again, DC and CB, they're perpendicular. So once again, this angle here is perpendicular, which gives us that right angle, ignoring that line. And we know that right angles are congruent, right? Right angles are congruent. So I'm going to write this as statement number 2. We could say that angle A, B, C is congruent to angle. So ABC was this angle here, A, B, C. That's this angle right here. Is congruent to D, C, B. That's this angle right here. D, C, B. Why? My reason why? All right angles congruent. All right angles are congruent. So we could write that. All right angles congruent. That's my reason why. Now, we're not told any other information, no. But once again, these triangles are overlapping. When triangles overlap, we always should look to see if they share anything. And once again, these share a side. They share this side right here, right? So we're going to put a double marker on it. They share this side right here. Now, my question is where's this side located, right? So where is this side located in our triangles? This is called BC. So we could write that BC, congruent, BC, right? This is our reflexive property. It's a reflexive property. But when we look at this, now let me isolate one of my triangles here. I'm going to draw on the inside of it so that we could see what we're talking about. Isolate one triangle. We'll use a orange color, right? I want to look at ABC. So triangle A, B, C, this triangle right here. And in this triangle, we have an angle, we have a side, and we have another side. What does that spell? Angle, side, side. What does that spell? Not a good word, right? That word is not allowed in my math class. So, do we have congruent triangles here? No. Let me switch colors so we can actually see this, because this no is important. No. No. Congruent. Now, does that mean that these triangles are not congruent? No. That's not what that means. What this means is we do not have enough information to prove that they are. If we were told that, let's say, we need different information, basically. We need to say that BA and CD are congruent, or we need more angles to be congruent, things like that, right? If we had that information, then yes, we could say that maybe by side, 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 these triangles are congruent. But since we don't know that information, and with the information we're given, we cannot say that these angles or these triangles are congruent. Let's move forward. So, I just answered this question. How can we show that these are congruent by angle, side, angle? So I'm going to mark up the triangle like we had it, right? Now, marking it up like we had it, we said that this is congruent to this. So we have sides there. We know that, we know that these right angles are congruent here and here. Those right angles are congruent. And then we said that this side is congruent, right? Because it's reflexive property, right? side right here. Now, it's asking us for a certain congruency statement. This is angle, side, angle. So we need another angle to be congruent in order to show that these are true. And we need that angle to be congruent on the other side of one of our sides that we know, right? So since we have angles here, right? We have an angle, we have a side, I need an angle over here. But if we look at our triangles, we don't want this other big angle. What we want is this angle on the inside right there and right here. Those are the angles that they share that will give us angle, side, angle. So we would need to know that angle DBC is congruent to angle ACB. And if we know that those two are congruent now, apologize. Now we would have angle, side, angle. Now, once again, some of you may have not seen this right away. Some of you may not understand this. If you need to, you could pause this. If you're in my class at the moment, raise your hand virtually and ask more questions about this. Say you're confused, you don't know necessarily what's going on. Maybe I could explain it a little more to you. If not, be sure to ask your teacher or leave a comment in this YouTube video down below, something like that, right? Because it's important that you understand what we're looking at here. Also, don't be afraid to be like, okay, let me just keep watching some more. Maybe I'll be able to come back to this and figure it out. Practice, practice, practice. I know that seems annoying. It seems silly. But the more you see these types of problems, the easier they are going to become. They were extremely hard for me at one point. The more I saw, the easier they became. It's just exposure and seeing it over and over again and recognizing patterns, right? And with that said, let's do a little more. Let's recognize some more patterns, right? We have another example here, right? This one says, suppose that AB is congruent to AC. What additional information would you need to conclude that ABE is congruent to ACD using angle, side, angle? So first of all, let's mark off the information we have. So I'm going to start off with red. That's usually my starting color. So we're saying AB is congruent to AC. So where's AB? AB is this long side here, and AC is my other long side here. Okay. So if we're looking at these long sides here, then what triangles are we looking at if it says ABE, ABE, and ACD? That's these triangles here, right? So we're ignoring this bottom part. Let me black that bottom part out so we can ignore it, right? Down here, scribble this out. I don't want to look at this right now. I'm ignoring this. I'm going to color it in just so we can pretend like it's not necessarily there. We're ignoring this. Ignore that, ignore that, ignore that, ignore that. That doesn't exist, right? It's just a mound of dirt that it's sitting on, right? So we have those two triangles, ABE and ACD, right? Now, they want to know by angle, side, angle. Well, we're only been given one side here. So we need to figure out, well, there has to be an angle already here that they're given. And once again, these two triangles overlap. We have ABE and ACD. They overlap, and they actually share this angle right here. So we could say that angle A congruent to angle A. Once again, why? That's my, whoops, I don't mean to have an equal sign there. Getting sloppy with my writing. Get rid of it. But angle A is congruent to angle A. Why? Because it's the reflexive property, right? This is congruent to itself. It's congruent to itself, right? Now we need another angle, because if we look at this, right, we have an angle, side. So they want us to do this by what? By angle, side, angle. So we need another angle. So if we follow along here, angle, side, what angle's down here? Right here. This angle right there. And that would give us my other angle. And if I do it on the other side, angle, side, where's my other angle? Down here, angle, boom, boom. What are those angles? What are the names of those angles? We could name them angle A, B, E, and we could say it's congruent to angle ACD, right? We don't need the equal sign there. I keep writing that equal sign. This is the information we would need to know that we're not told. This information in green, I could tell from the picture, right? I don't need to be told that. But this information right here, I need to be told something. This is the information we need to know. We need to be told in order to prove this by angle, side, angle. That's the information we're missing, right? And if we have that information, now we have our angle, side, angle. Keep moving. But what if we have the same situation, ABE and ACD, but we want to know by side, 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 right? We want to say, hey, well, side, side, side. How do we do that congruent? So once again, are we using the same triangles? ABE, yeah, and ACD. Yes, we are. So what do we know from this? Well, once again, mark off our original statement that we have up top. It says, suppose that AB is congruent to AC. So boom and boom, those are congruent. Once again, I'm going to scribble out the part that I'm ignoring. I'm ignoring this section down here, right? Ignoring this section down here. And we want to say by side, 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 that means all three sides of one triangle need to be congruent to all three sides of the other triangle. So let's mark off my second set of sides here. I'll do it in green. So we have that AB is congruent to AC. That's what we were told. We were given that. But what other information do we need to know? Next up, we could say that BE is congruent to DC. Right here, BE and DC. Right there. We got boom, boom, boom. Now, the confusing part here, get ready, it's going to get a little confusing. So we need this little information right here. We said BE congruent to, that should not be DC, that should be CD. Following corresponding parts rule. Need that to be CD. Sorry about that. Also, I do not like this color that I chose. I mean, I like it personally as a color, but it's kind of hard to see. But the other piece of information we need is actually, I need to show that DA and EA are congruent, right? Boom, 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 boom. DA and EA. Okay. Congruent. And if we had that, then we would show it by side, 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 right? Then we would be able to show it by side, side, side. That would be all three sides of the triangle. We would have side, side, side. Next, what about side, angle, side? Well, let's get into it again, right? Let's see what we are given. This one's going to be a little simpler, right? If we need to know this one, because we already told information, right? But once again, let's use information we know. We already have sides and we have angles that we knew were congruent. Our sides that were congruent were AB and AC. That was my given information up here. Then, as we said the first time we saw this problem, we know that angle A is congruent to itself. So we have angle, side. Now we need to figure out the other sets of sides on this one, which were the ones that I just marked off, which is DA and EA. Then we'd have side, right? So this would actually be, and this is where it gets a little confusing, we would have side, angle, side, right? So that would be for one triangle. Let me change colors so I can show you. So for the one triangle, we would have side, angle, side. And then for my other triangle, it would kind of be in reverse. Let me change, let's do a different color, red. We would have side, angle, side, right there. Actually, not with that one. Sorry, whoopsie. Let me show this side next to the side that's supposed to be by. Would be side, angle, side here, right? So that's the way it's organized in our brain. But what parts do we need to be congruent, or what information do we need? We would need to be told that DA is congruent to EA, right? DA is congruent to EA. Once again, practice, practice, practice. I know this is a lot of information. I know it's be thrown at us left and right. But when we practice this, the more we see, the more we'll understand. The more we see, the more we'll understand. And let's look at our last little bit for today. Question number 6 on page M243. The last one was on 43 also. I forgot to mention it. Sorry about that. It says, Simone says that since triangle ABC and triangle DCB have two pairs of congruent corresponding sides and congruent corresponding angles, then the triangles are congruent by side, angle, side. Is Simone correct? So we do have things that are congruent here, but we need to check what order are they congruent in. What order are they congruent in? So we have these angles here that are congruent. So we'll say angle, right? On each one, we have an angle in one triangle and my other. Then we have these sides. We say side. And then we have this side, which is congruent to itself, side. But what does that spell for each of my triangles? Either SSA or ASS. And we know that that doesn't work, right? There's no SSA or backwards in math. So this does not work. They are not congruent with this information. They might be congruent. That might be true. But the information we're given, we cannot say that these triangles are congruent. We do not have that information, right? So we cannot necessarily say, and it's because of the order of the information we're given. Since it's in that angle side side or that side side angle order inside of our triangles, that's why it doesn't work. If it was side angle side, then it would work. But since it's angle side side or side side angle, that's why it will not work. And that is the end for the notes today. Whew, we could all take a deep breath. There was a lot thrown at us, right? A lot of information. We saw a lot of work being done. And it may have been very overwhelming. But one thing we need to remember is we're just starting out here, right? This is like if someone threw a football at you the very first time when you were a baby and you wouldn't be able to catch it necessarily. Tom Brady throws a football at you, you're not going to be able to catch it. If Cristiano Ronaldo kicks a soccer ball at you and you're goalie, you're probably not going to be able to stop that soccer ball, right? Same thing's happening here. You're being thrown professional problems, right? You're not going to be able to do them right away. It takes practice. It takes attempts, and we're going to do that together, right? So practice, 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 taking notes, paying attention, and trying the problems yourself. Trying all this yourself will make you get better at it and help you learn. But good work today. I hope you guys took some notes. If you have questions, feel free to reach out to me, whether you're in my class, your teacher, if you're learning this in your classroom, or drop a comment down below and I'll try to get back to you. But thank you guys. Be safe, have fun, good luck, and I'll see you next time. Peace.